a Ring Chime. I bought this off eBay for spares or repair. I think I won it for 99 pence. Apparently it was advertised as not having any power, so we shall plug it in and see what it does. I guess that goes on like that. Right, I shall just find a power socket. Right, I've got a power socket. And it doesn't appear to be doing anything. Now, apparently this Ring logo here is supposed to light up blue. And there's a little reset button on the side here, which doesn't appear to be doing anything. So I think we'll take it apart and see if we can figure out what's wrong with it and hopefully repair it. So it looks like there's 2 screws to remove here. And we'll just put them to one side so we don't lose them. And then we'll see if we can pry this open. Alright, now because it's just been plugged in, right, it looks like we've got a little power supply here. And the main board, looks like there's an antenna here that's glued to the top. Yeah, it looks like there's two sort of standoffs here that hold the board in, and 2 screws down there. And we should just be able to disconnect that little antenna if we get rid of this bit like glue stuff. And I guess those 2 wires must go to the speaker. There's not actually a lot in this. I'm kind of suspecting the power supply. Tell you what I might do. I might see if I can get rid of some of this goo, like so. And I can see something there. It says VDC, but I can't see what voltage it is. I don't know if we can get rid of this label here. There we go. So 5 volts DC. So I think what I'm going to do is connect this back up, and we'll just see if we get 5 volts DC. Carefully plug this in. I'll try not to electrocute myself. And we'll see if we get 5 volts DC on the power supply. And we don't. It looks like there's been some voltage there which is rapidly declining. And it looks like this cable here has been caught or something at some point. Right. Right, let's give this a moment to hopefully discharge. And we've got a little power supply module here. A little bit awkward to work on this, but I think I'm going to check if there's any voltage in that capacitor first, which is about here for the mains one. And yeah, there's still a bit of voltage in, but it's going down. Well, seeing as there's voltage in there, we know that the fuse is intact. We know the bridge rectifier is okay. So I think the problem is going to be further on. I wonder if it's something like the output capacitor on this, which it looks like there's 2. Or it could be that capacitor there. Actually, there's 2 capacitors here. So I guess those are the mains smoothing That one there could be a bootstrap capacitor, and it's 6.8 microfarads at 50 volts. That'll be one of the output capacitors, I suspect. And it looks like it's in parallel with that capacitor there. So 6.8 microfarads, 50 volts. This mightn't work in series, but sorry, in circuit, but we'll try it. $18 microfarads, and what was it supposed to be? 6.8. That could just be because we're measuring other components in the circuit. So so that appears to be 680 microfarads at 6.3 volts, but bearing in mind it's wired in parallel with another one, and it's connected to the circuit as well. I wonder if there's any shorts on the circuit board. That's the other thing it could be. Let's put on the ohms, and let's just measure across here. No, I would say that seems okay. There's no shorts there, I can see. There's a small ferrite bead there. There's a couple of capacitors. Let's just see if we've got any shorts on these caps. Nope. Try this one. Seems a little bit low, that, but it's climbing back up. So I think I'm going to pull those two capacitors out. I might pull that 50 volt one out as well. Right, I'll pull the 50 volt one out first, and we'll see what that measures out of circuit. Let's see if we can pull it out. Let's get a bit wick on those holes, just to clean them up a little bit. I just want to clear the hole. There we go. Right, so let's measure this one out of circuit now. .2 microfarad. Well, it seems okay, that. Let's say they have got a bit of a tolerance. So let's see, that seems okay. Trying to get her back in though. Might be a little bit fun. again. Let's give it a little bit of a clean. I thought that was a blown track across there, but I guess that's a spark gap or so. Because there's some separation between the output side and the input side there. That's what that cut in the circuit board's for. And because those two are soldered and look like points facing each other, I guess that's for like a spark gap. In case this gets zapped by lightning or something, I guess it's got a path to get back or whatever. I wonder if I put 5 volts onto this just to check this part of the circuit's working with the bench power supply. Right, I think I'll hook the bench power supply up and we'll stick 5 volts into this and we'll see if it lights up and does anything. And then we can definitely, I mean, tell you what, I'm going to undo this first. Let's see if I can clip this back in so it's not flapping about. And let's see if I've got any voltage on there. And we do. I mean, that's not under any load. But we are getting 5 volts there. Try and get this thing out now. Right, I want to tag a couple of wires onto this and we'll put some voltage in with the bench power supply. So I'll just tag a couple of wires on there once I find some cable. And I'll be back in a moment. Right, I've got the bench power supply hooked up and we're putting 5 volts into it. It still doesn't appear to be doing anything. It's not lighting up blue and the reset button isn't actually doing anything either. And it's drawn very little current, if any at all. So we'll just check we're getting voltage into it, and we're getting about 4.98 volts there. Now there's a couple of little what looks like voltage regulators down here. I might have to bring the microscope in so you can see a bit better. If I stick this on the ground there and I just go on, let's say, this capacitor here, double check we've got the 5 volts. Yeah, so that little regulator here seems to be dropping it down to 3.3 or 3.25, and then there's another little voltage regulator here which seems to be giving out a 1.8 volts. So I would say that those voltage regulators are working correctly, but it still doesn't seem to be doing anything. There's a small chip here which it's got marked on it DAC 3100, which goes to the speaker. So I guess that's a digital to analog converter. And this chip here by Texas Instruments, which is a CC 3200R1. I guess that's an integrated processor and Wi-Fi chip. And this chip here It looks to be some kind of SPI flash. So I think we may have to take this board out, but I don't know whether we'll be successful repairing this or not. I mean, it could be a firmware problem, it could be something that this processor has failed, but so far we seem to be getting voltages into it and they all seem correct. So I think I'll switch the bench power supply off for now and we'll see if we can get this board out. Be a bit quieter with the power supply off because it's got a rather large fan in it. So you can get this bit of glue off, like so, and then we'll have to remove this little Wi-Fi antenna. It might be easier to remove the speaker wires as well. Actually, we might get rid of them. So there's nothing on this side of the board apart from a couple of LEDs and a switch. So it looks like everything's on the other side. And also there's a couple of jumpers here. There's like 3 sets of jumpers here, marks J1. I think J1, J2 and J3 are similar. Yeah, J15, J13 and J14, so I'm not sure what they're for. Well, I'm not sure, like I said, if we're going to be successful with this one or not. I'll just connect this speaker for now, and I think we'll bring the microscope in and we'll have a look over the board. See if we can see anything obvious. This out of the way and we'll bring the microscope in and we'll have a look. Right, that's where I've just removed the speaker from, and that's the CC3200 chip that I just mentioned earlier. A bit better view there when we angle the board slightly. Looks like a 4 megahertz crystal there maybe. That looks like an antenna filter, which goes up to the antenna there. Now, one thing I've just noticed there, so just a scratch on that capacitor maybe. Yeah, it's probably off my test probes. I thought that was a crack in that inductor there, but it might be off my test probes possibly. So there's 3 inductors there. Looks like there's an inductor there, an inductor there, an inductor there, and a couple of capacitors. So, and those look quite big tracks. So I guess this chip might generate its own voltages internally, and use these capacitors and inductors to do that. What's this here? Looks like another crystal there possibly. Looks like we've got some programming headers there. That's the SPI flash, which is a 25Q64. Looks like some kind of small IC there, HS1, I'm not sure what that's for. And that's the digital to analog converter. which it looks like goes to the speaker here. You can see one of them coming through here and going to there, and I guess the other one probably comes out of there somewhere and ends up at this point. Yeah, through there. Actually, that could be both of them. Going through here and ended up with the contacts for the speaker. Well, there doesn't appear to be a great deal in it. So that's the little power supply that I measured earlier. This chip here seems to generate the 3.3 volts, which gets to round about here, and this one here seems to generate the 1.8 volts. I was just seeing where those kind of went. Little tiny IC there, not sure what that one's for. I can't see anything obvious on here. I can't see any blown components or anything. That's just a ferrite bead which puts the 5 volt through to the regulator here, which is working because we're getting voltage out of it. And I guess H1 is just a couple of test points that you can use just to see if we're getting the 5 volts there. It might be worth checking some of the voltages. That's just the quote, I think, on them. Might be worth checking some of the voltages on some of these caps just to double check. Or some of these inductors rather. I might see if I can pull a data sheet up for this chip, and then we might get some inkling of what's going on with it. I've pulled up the data sheet on the CC3200 chip, and I've got it hooked up to the scope here as well. We'll just turn on the power supply. I just thought we'd check that the chip's getting all of its signals. So the first thing I'm going to do is check that this is actually a 40 megahertz crystal. So if we put this on here, and if we look at the scope there, we're getting the 40 megahertz clock. So that seems correct. There's another oscillator further down which is 32 kilohertz apparently for a real-time clock. So we'll just go on this pin here, and we might have to adjust the scope slightly. And there we go, 32.7 kilohertz, so that seems okay. We don't seem to be getting any data on the flash chip here. Tell you what, we'll just check that the processor isn't in reset, which apparently is pin 32. So I shall just turn this board around a bit, and pin 32 should be that one there. Just have to adjust my scope slightly. Yeah, we're just getting over 3 volts, about 3.2 volts. If I just turn the power off and back on there. Yep, so the processor isn't being held in reset. We've got clock signals, we've got all the power. Now one thing I have noticed is the chip generates some voltages internally using these inductors and capacitors around here. So if we go onto this one here, we can see we've got a voltage. And if we go on to this one here, which uses this inductor, we have no voltage. Now it's supposed to be for the power amplifier, which I guess is for the RF, for the Wi-Fi. Now it could be that the chip hasn't booted that far yet, so it hasn't actually initialized this part of the circuit yet, but there's no oscillation and there's no voltage on this part of the circuit. If we go on to this one here, again we can see we've got a voltage of about 1.2 volts. I think that was for the core. One's for the RAM, one's for the core, and one's for the power amplifier, but there's nothing going on this one. If you probe the inductors, you can see we're getting a set of pulses there, and if we probe this inductor here, you can see again we're getting a set of pulses, and if you probe this one, we're getting nothing. And like I say, one of the things that it does is it boots off external flashes, so when you power it up, it tries to boot from this chip here, and we should have a clock and some data signals here. I think this pin here, which goes to that pad, is the clock, and if I just switch it off and on, and you check the scope there, we've got no difference whatsoever. There's no clock line going there. There's no, it's like the processor isn't, it's like the processor's just died. So I'm fairly confident that this chip here has failed. Now we may possibly be to get a replacement chip, and if I do that, I'll continue the video from there as a revisit, but the way it stands, I think we're a fail on this one. So, well, I think that was it. I'm trying to repair a Ring Chime. So, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.